Hello and welcome to the Tazama Rule Studio series. We'll be walking you through the Tazama Rule Studio, which is a solution that allows users to design, test, and create fraud detection rules without needing excessive engineering. So, before introducing the system, let's briefly look at the current challenge. So, today, creating new rules for Tazama requires writing extensive code. And every time a new rule is introduced, developers must manually create the logic, structure the rule files, and then separately write corresponding test cases. This makes the time consuming process even more difficult and it increases the risk of inconsistencies or human error, especially when there are frequent iterations or when quick updates are needed. So the Tazama Rule Studio addresses this by making the rule creation process easier through a drag and drop interface. Users can configure rule logic directly within the UI and define their test scenarios and validate the behavior using customizable test data before deployment. Once these rules are deployed, they become part of the live FRMS rule processing flow um, where the goal is basically straightforward. We are seeking to shorten this rule development cycle and increasing the confidence in the rule logic before rules actually move into production. All right, so let's take a practical example for this. Let's say a customer initiates a credit transfer exceeding $10,000. So, from a regulatory standpoint, this transaction should be evaluated against a predefined threshold rule. However, let's assume at this point that no such rule exists in the system. So, of course, a new rule must be introduced, and normally this would require custom development, as I mentioned before. This process is time consuming, it's dependent on programming, it's dependent on humans writing code, and there is no standardized validation workflow either to ensure that the logic behaves as expected before going live. And this is exactly the gap that the Zama Rule Studio is designed to address. Okay, so now let's see where TRS fits into the broader FRMS pipeline. So the ISO 222 messages enter the system and are ingested by DEMS, where they are, which is the dynamic event monitoring system, where they are transformed and stored in the data model. This part of the process is already covered in the TCS demo video series, so you can refer to that. Um, and the event director identifies applicable scenarios and determines which rules should be executed. And then now this is where the Tazama Rule Studio comes into play. Now, let me clarify that TRS is not part of runtime execution. It is the design and configuration layer only. It's where we create new rules, we structure them, we test them, and we validate them before they ever reach the live pipeline. So once approved and deployed through CI/CD, those rules become available to the rule processor. The rule processor evaluates transactions, submits the result to the typology processor, um, and typologies are scored. Finally, the transaction aggregation and decision processor, which is the TADPROC, consolidates the results and an alert is issued to the CMS if threshold or risk conditions are met. So, in summary, TRS sits above the execution layer, but it enables rule design, validation, and deployment into the live fraud monitoring ecosystem. Right, so now let me briefly outline how TRS is structured so that before we go into the system demo, you're familiarized with the terms that we're going to use. So the Zama Rule Studio acts as the configuration layer of the ecosystem, like I mentioned. This is where rules and their corresponding test cases are defined using intuitive drag and drop nodes. And once configured, they are simulated and then reviewed through a maker checker workflow before being deployed. We support two types of simulation. First is the rule only simulator, which allows isolated rule testing, unit testing against configured test cases using standard NATS utilities. This is useful for validating the logic of the rule independently. And then second is the DEMS-driven simulator, where a payload is ingested through DEMS to trigger the configured rule in a more realistic end-to-end manner. So from an environment perspective, TRS supports clear separation between source and target environments, typically staging or dev, and production environment, in, which basically would ensure controlled deployments. Version control is also managed through structured GitHub branches, including staging, development, and production. And then finally, the entire workflow is governed by defined roles, which are maker, approver, and deployer. So now let's look at the use case we'll be covering for the video series. Let me quickly walk you through it. Right. So the rule creation process starts with the maker. Right, the maker logs in, enters the rule's basic details, and as soon as the initial details of the rule is saved, the GitHub repo is initiated with a skeleton structure of a rule, which just contains the basic template of it. Then the maker builds the rule logic and its test cases um, using the drag and drop builders, like I mentioned before, and syncs the configuration. So this is the point where the configurations are deployed from the staging branch to the dev branch on GitHub. Right. And now the maker can run simulations to validate the behavior. Once successful, the rule is sent for approval. At this stage, the approver reviews the rule configuration, reruns simulations if required, and ensures that the logic aligns with the regulatory expectations. If everything looks correct, the configuration is approved. The approved configuration is then deployed to the target environment using a controlled CI/CD pipeline. And in the background, GitHub branch management ensures proper version control, starting from staging to development environment, and then finally merging into the production branch. So now I think we're ready to move on to the TRS system demo. So that's it for this video. Stay tuned for the next ones. Thank you.